Hey guys, it's Miss Silva, and in this lesson we are going to be simplifying radical expressions. So our learning target is to be able to simplify the square roots. To be successful, we need to be able to find the largest perfect square, find the square root of that perfect square, and write it outside the radical. And then we can multiply and divide the numbers inside the radical and multiply and divide the radicals, or I'm sorry, the numbers outside the radical. Talk about radical numbers. Just like we simplify fractions, we simplify radicals. So for instance, if we had 2 divided by 4, we would simplify that to 1/2. Radical symbols look, so you see this is my radical symbol, looks like a check mark. The number inside the radical is called the radicand, and the number on the outside is my coefficient. Remember that when there's a coefficient, we're basically multiplying that number times the square root or a variable. When working with simplification of radicals, we must remember some basic information about perfect squares. One is also a perfect square, but it's irrelevant when we are simplifying, and that's why it's not included in our table. So let's look at our perfect squares. Now 4 is considered a perfect square. Now the reason 4 is considered a perfect square is because if we had 4 and this was a square, then we would know that we had 2 and 2. The sides had to be 2 to give us a square of 4. And then for the next one, if we had 9, what would the side lengths have to be? Well, they would have to be 3. So 9 is a perfect square. If we look at, let's say, 11, 11 is not a perfect square because no two whole numbers will give us 11 as a square. So if my perfect square is 4, then our side lengths would be 2 times 2. A perfect square of 9 would have a side length of 3 times 3. 16 would be 4 times 4. 5 times 5, 6 times 6. Instead of writing 2 times 2, we say 2 squared. 3 times 3, we say 3 squared. And then 4 squared, 5 squared, and so on. So when we do the square root of them, we're basically looking for the length of the side. So if we do the square root of 4, we get 2. Square root of 9 is 3. Square root of 16 is 4, and so on. All right. Now when we look at simplifying radicals, we look at the number under the square root sign, or the radical symbol, which is my radicand, and then we try to divide the largest perfect square. This is my list of perfect squares. Now if I look at 24, I want to start dividing it by, let's say, 9. So I'm just going to do some side work over here. We're going to do 24 divided by 16. That does not divide evenly. Let's try the next one, which is 9. 24 divided by 9. That does not divide evenly. Let's try 4. 24 divided by 4, and that gives us 6. So what we're going to do, instead of writing square root of 24, we're going to write the square root of 4 times the square root of 6. Now notice how 4 times 6 is still 24, so we're not changing the value, we're just changing the way it looks. So from here, we know that the square root of 4 is 2, and then the square root of 6, we're just going to write it. So to simplify square root of 24, we can simplify it to 2 square root of 6. Let's move on to the next one. Go ahead and try this one on your own. Push pause and come back and check your answer. All right, so if you got 3 square root of 3, you are correct. I did the side work over here for you all so you can see. Our number was 27, so the only one that would make sense to start with is at 16. Okay, let's look at our next example. We have 5 times the square root of 72. So for right now, this coefficient, we're just going to write it off to the side. And we're just going to worry about the number that's inside the radical, which again is my radicand. Now, if our number is 72, we want to go to our list of perfect squares, and I want to start with 49. Because I feel like 49, we know it's not divisible by 64. So if we start with 49, we might get somewhere. So go ahead and put 72 divided by 49 in your calculator, and you'll see that it does not divide evenly. If we do 72 divided by 36, we get 2. So then 72 is going to be replaced by the square root of 36 times the square root of 2. Now the square root of 36 is 6. So we're going to bring down this 5, bring down this perfect square, and then square root of 2. At the end, we want to multiply anything that's outside of the radical, which is 5 times 6 is 30. And then that square root of 2, there's nothing left. So we simplify it to 30 square root of 2. Go ahead and try the next one. Push pause and then come back and see if you got it correct. All right, if you got 6 square root of 6, you are correct. Now notice my side work over here. I started with the largest perfect square that I thought maybe could be divided by 54 evenly, and I had to go all the way to the perfect square of 9 to get 6. So we got square root of 9 is equal to 3. 2 times 3 is 6, and then we have the square root of 6 left over. You can always check your answer by going into the calculator, typing in both values, and seeing if they're equal. All right, have fun with your assignment.